Hi everyone, welcome to lecture of week 9 of ICT200 database design and development. This lecture is based on chapter 9 of the book which is on multi-user database processing. Let me share my screen. Before moving to the multi-user database processing in detail, let's define some of the activities and roles played by a database administrator. So whether it is large or small database, it requires administration. And data administration means the function concerning all of an organization data assets. So data assets are quite important in any organization to be managed properly, and that management activity is called database administration or data administration. Database administrator can be a person or could be an office with number of technical people, database people. um, Overall activity of a database administrator is to facilitate the development of the use cases usage of the database. So the number of application can be developed in the organization, and all the application can access database, um, and that facilitation is the activity of DBA. DBA carries number of roles and responsibilities, um, number of tasks he or she performs on day-to-day basis. But some of the tasks are quite critical, important, and some of them are listed over here. First activity is managing database structure. In any organization, database keep changing based on the requirement of the organization, and the change of the structure of the database is managed by DBA. In multi-user environment, concurrency is quite important aspect. So controlling concurrent processes is also one of the important activity. Managing roles and responsibility of the users of the database is taken care by the DBA, who can access what kind of access up to what level, whether the person can modify, change database content or not. That is the responsibility of managing processing of rights and responsibility. Developing database security is another activity which is quite important these days when there are number of attacks from the outside happens to the database. Recovery, backup and recovery. Database backup and recovery is one of the most critical component of any DBA office. That's very important task, and they normally take backup of the database on a regular basis on a certain frequency, whether it's weekly or daily. Recovery happens if the database fails or some failure happens at the hardware or software level. So that recovery is also done by the DBA. Managing DBMS, database management system, by installing some patches, or some changes happens in the database management system, and also updating and changing data repositories, important activity which is done by DBA on a regular basis. um, let's define a multi-user database. What is it? Multi-user database is the database which is used by multiple different users at the same time. So for example, in the middle you can see there's a blue box. On top it is a database, and there are three terminals, and all these three terminals are sending different queries, SQL queries, and at the same time, and this particular database is able to process these three queries at the same time and also returning results to them. So that kind of activity happens at the same time is the multi-user environment. Concurrency means database is able to process multiple users requests at the same time and affect multiple transactions because its capability to process multiple transactions and multiple processes, uh, and that makes actually database management systems DBMS different from the normal data storage. Normal data storage like storage of flat files or spreadsheets cannot provide that kind of concurrency facility. You can't use them for multiple processes at the same time. Uh, that's the big difference between the database management system or database system to the flat files. Concurrency control is activity which is coordinated by the DBA also. It acts the action of processes that operate in parallel. Multiple processes are running parallel. It allows access of shared data and therefore potentially interfere with each other. So you can see here in the middle, in the diagram, in the middle box, the gold color is the database, and there are two processes, one in blue color box and another is in green color box. These both processes are trying to access shared same record, same data, and trying to do some modification. So and they are interfering with each other obviously because both of them are accessing the same piece of data and trying to make changes. So that's how the concurrency is happening, and that has to be controlled. Otherwise, there would be some problem in getting consistent record. We will discuss that in later stage. Atomic transactions is a set of activity. You can say it's a task that is also called the logical units of work together, which should be either completed in a transaction or none of the modification, none of the task, none of the work should be performed in a transaction. So for example here, suppose application in the diagram shown actually, there is application, and in that application there are two tasks are associated. Task one, update one in some table, and then actually update two is some other table. So either both tasks should be performed, and both tasks together is called logical unit of work, LUW. Update one and update two together is one unit. Either both updates, update one and update two, should be done, or none of them. Suppose if update 1 is completed and somehow system fails to do update 2, so it should be rolled back. It should be brought back to the original before update 1 was done. So that's how actually it is called atomic transactions. So any transaction, number of activity may be involved in that. It should be completed or it should be uh, revert back to the original. No modifications should be done. That's the atomic transactions. Concurrent transaction processing means suppose when two transactions are being processed against a database at the same time, they are termed concurrent processes, which we have already seen that actually concurrency and concurrent transaction processing is the same thing. In this particular diagram, you can see there are two transactions, T1 and T2, and both of them are fired to the database at the same time. And the first transaction begins taking a record A and adding 100, suppose $100 here, $100 to that particular record. And before it goes to the next level of doing modification, because dollar $100 was added to A, but dollar $100 has to be reduced from the record B. So for example, it is credit and debit. So if you are taking money from one account, you have to deposit in other account kind of. So account A has got $100, so account B has to get actually $100 less. There should be some reduction in account B. But in the meantime, transaction 2 started before B was reduced, and transaction 2 took actually A and B recorded at the same time, the value of that, and multiply the 1.06 interest, you can say, and that commit was done. The transaction was completed. It means transaction T2 came into in between the T1. So that's interleaved. Interleaving means T1 was not completed. In the middle, it just completed one statement, and then in between transaction 2 came and it completed the whole transaction of it, and then T1 did some work. So that's how you can see some changes happened over, some transaction has happened in between. It is called interleaved. So two transactions are done simultaneously, but it appeared actually they are interleaved, but it should be seen it is serially done. That will be discussed in the later. So currently concurrency is here because it appears there are two transactions are completed simultaneously in reality, but both of them are interleaved with each other. Lost update problem. Lost update problem is one of the very critical problem. If two transactions are interleaved and one transaction make the modification uh, which is not completed by the other transaction. So for example, transaction 1 took a record which was shown 10 stock. Suppose this is a retail shop and there are 10 stocks available of certain item. So transaction 1 actually saw there are 10 records, and transaction 2 also saw actually 10 records at the same time. Then you can see in the bottom, transaction 2 completed transaction 2 completed it sold two items from the 10 record, and transaction 1 also sold one item from that. Transaction 2 completed its whole processing before transaction 1, and the final outcome was 8 in transaction 2 because only two items was sold by transaction 2. So the final item is number of items left in the stock is 8, and that is gone into the database number 8. But transaction 1 actually completed its activity after that, and it found actually the total stock left after selling one is 9. So it means it will go back again, it overwrite 9. It means transaction 2 the activity is overwritten by transaction 1, and that's how the I, two items which was sold by transaction 2 is lost. So this way the transaction 2 is lost, and it is that's why it's called lost update problem. The update made by transaction 2 is lost, and that's how the database is not going to be consistent, because the total sale happened of three items, but actually database was updated with only one item sale, and that's how the consistency gone. And this is one of the biggest problem in concurrent processing on multi-user processing. Let's see the solution for this kind of problem. And the solution for this kind of problem is covered in the following slides. So first of all, actually, important part is putting resource locking. So suppose if transaction 1 in the previous case um, locks the transaction particular record uh, after taking the stock, and then update the whole record to the 9, and then transaction 2 take the 9 as a stock and make the changes, then the total deduction from the total stock would be 3. But since locking was not done, and both of them actually read at the same time, and both of them did the modification one after another, and one modification done by transaction 2 was lost. So that's how the remedy for this is a lost update or inconsistency is the resource locking. So resource locking, once multiple applications are obtaining copy of the same record, it should be locked so that actually other process should not be able to take it. So there are two ways of doing locking. First way is in implicit locking. Implicit locking is done by the database management system automatically, and explicit locking is done by the process for the by the user by requesting that actually I have taken this particular record and I'm going to do some modification in that record. So we normally fire one statement, one kind of command to lock that particular record so that other process or other applications should not be able to take it. So to avoid that one, explicit locking is also done. Let's understand actually different type of locks can be applied, and its granularity. The first granularity with the top level is database. Entire database is locked. Support not only table, the whole database. So one application actually access that database and it locks it so that the other applications should not be able to read any content from the database or modify any content of the database. That is the highest level of locking, which makes database very inefficient. A lower level of that is at the table level. So if there are multiple tables, certainly you can lock that table which you are reading. That also makes it a little bit inefficient. A better and quite efficient way of doing is that the row level locking. So just lock the row which you read or which you are going to modify. But better than that, actually, it's if you want to make it more efficient, there's another way of locking at role level is exclusive lock and shared lock. Exclusive lock applies when you are going to read a record and then you do some processing to modify it, then it becomes exclusive lock. But if you just want to read and do the modification in your process, but you don't want to actually update the database, then it becomes a shared lock. So multiple processes can read that, but none of the intermediate updates is going to happen there in the database, and that becomes a shared lock. So in that way, row locking also gets more efficient, and exclusive lock is applied only when it is required. Serializable transaction. Whenever multiple users are using database and they are asking for the same record to read and modify, it should appear as if both the transactions, both the processes are running one after another. It's, however, in real sense, both the transactions are interleaved. As we saw, actually, interleaving means two transactions are um, in this particular slide 8. Two transaction T1 and T2 are interleaved. Transaction T1 begins, then transaction T2, before transaction T1 is finished, T2 is started and it finished. But actually it is interleaved. However, this interleaving should happen in concurrent processing, but at the end actually it should feel like that actually transaction T1 and transaction T2 are processed serially, means T1 finished, then only T2 started. That kind of serialization is called serializable transactions, and that can happen only if you apply two-phase locking. Two-phase locking technique is quite popular technique which is used to make sure that transaction should not make a lost update, or there should not be any inconsistency in the transaction. So we will discuss about the two-phase locking in the next slide. Two-phase locking here is in two sections. First, if a transaction starts processing, that transaction should be allowed to take lock on all the records which they are going to process. So in the previous slide, slide 8, which we saw, the transaction T1 is doing two activity. One, it's adding $100 in transaction, $100 in record A, and it's deducting $100 from record B. So these two statement is going to be processed. So in two-phase locking, when transaction T1 starts, it should lock A transaction, means record A and record B at the same time. And when it is locking, the T2 will not be able to access A or B both. It should not be able to access that. So in two-phase locking, the, both records A and B should be locked, and at that time it's called the growing phase. It's locking. Once the first lock is released, in the case of if transaction T1 released A, it should not be able to lock any other record. So it means when it releases A, T2 can start processing. But actually it when T2 is going to start processing, certainly T2 can acquire A, but T2 can't acquire B. However, T2 required to acquire A and B both to complete their transaction. So it means T2 can't commit the whole processing before transaction A transaction T1's completion. So that's how actually it interleaved, but it's not going to interfere and make an inconsistent update. A special case of two-phase locking is mentioned over here in this slide. Locks are obtained throughout the transaction at the same time, and no lock is released until the commit or rollback command is rollback means whatever transaction is whatever part of the transaction is done, and if there is any failure happens, it has to go back to the original state. So rollbacking, it means in the previous transaction in T1 we saw the A was transaction A was added $100. If T1 is failed somehow, it has to go back and A should be recovered to the original number. So this strategy is very easy to implement, and that's why it's very popular. Two-phase locking is quite popular in database implementation. Um, the last part of this part of lecture, this last slide of this part of lecture is the deadlock. Locking is very interesting and important, but actually it appears in the deadlock situation. What is the deadlock here? Suppose there are process 1 and process 2. in the right hand side diagram. Process 1 requires to record resource 1 record and resource 2 record. Process 1 is able to get record resource 1 and locks it, but it's not able to get resource 2, so it's not able to complete. Similarly, process 2 gets the resource 2 lock, but not able to get resource 1 because both processes requires both of the records to complete their process. So process 1 requires resource 1 and resource 2 together at the same time to do the processing. But since both of them are locking one of the total resources required by them, and that's how they are in the locking situation, in the deadlock situation, because process 1 is not releasing resource 1 and process 2 is also not releasing resource 2, and they are in the deadlock situation. Under that situation, there are two ways of coming out. First way is preventing deadlock. You should not allow, suppose process 1 is able to get resource 1 but not able to uh, get resource 2, automatically it should prevent the resource 1. So it should release actually lock of resource 1 immediately. That's a preventing deadlock. Either it process 1 should be able to get both lock, or it should release whatever lock it has got. That is called the preventing. And breaking, sometimes if database administration database DBMS, database management system, is able to detect if there is any deadlock, it breaks forcefully, it aborts one of the process. So suppose process 2 is aborted, then process 1 will be able to get actually resource 2 and can complete the whole processing, and that is called the breaking deadlock. So DBMS take decision and decide which of these two process should be aborted, so that actually one of the resource should be released and one of the process should be able to complete. uh, that's part one of the lecture, and I'll get back to you with part two of this lecture. By that time, go back and get a cup of coffee and 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 understand actually part two of this lecture. Bye for now.